Alright, we're going to start our chapter 5 today, and it's on trigonometry still, but we're looking at trig graphs now instead of looking at trig in terms of the unit circle and so on. But this does come from the unit circle, so let's kind of quickly review unit circle coordinates. So we know at 0 degrees, our coordinate is 1, 0. We know at 90 degrees, our coordinate is 0, 1. At 180, it's negative 1, 0. And at 270, it's 0, negative 1. And we also know that our sine coordinate is the second one, and our cosine is the first one. The other thing we also know is at, say, 30 degrees, our point was root 3 over 2 and 1/2. At 45, we had 1 over root 2 for both. And at 60, we had 1/2 and root 3 over 2. And then all those coordinates just repeated themselves as we went around. So if we went to this coordinate, our sine was negative root 3 over 2. Then we had negative 1 over root 2. Or sorry, still positives. And then we had 1/2 lastly there. So our sine quadrants were positive in the 1 and 2. Then they repeated themselves again in the next quadrants, but these ones were negative. So we had negative 1/2, negative 1 over root 2, negative root 3 over 2, and the same thing in this quadrant, going back down again. So negative root 3 over 2, negative 1 over root 2, and back to negative 1/2. So if you looked at your unit circle just at the sine coordinates, we would see that they just sort of repeat themselves around and around. So our sine graph is basically just plotting those coordinates. So if we started at 0, we're starting at 0. That was our sine coordinate. Then we went up to 1/2. Then we went up to 0.7 roughly is 1 over root 2. Then we went up to 0.86 is root 3 over 2. By the time we get to 90 degrees, we're at 1. And then the next quadrant just repeated itself going back downwards again until we got to 180, which we were at 0 again. Then we did our negatives, so negative 1/2, negative 0.7, negative 0.8 to negative 1. And then we went right back down again, all the way back to 0. So if we actually plotted all the unit circle, we would get that section of the graph. Then if we went around the unit circle again, obviously this graph would just repeat, or if we went backwards, it would keep repeating in the negative direction. So that's what we're doing today, is tying a unit circle to our graphs and then figuring out how we can get a graph and an equation. So we'll start with just the sine coordinate. So we know they go from 0 to 1/2 to 1 over root 2 to root 3 over 2 up to 1, and then it back down to 0 to negative 1, back down to 0 again. So we get these repetitions going around and around, so we call this a periodic function or a sinusoidal. So you can see where the word sine comes from. That's part of a sine graph. So the question is, what do we know about a sine graph? Well, if it starts at 0, we know we have a y-intercept of 0. We know we have a maximum of 1 and a minimum of negative 1. So those things never change for a sine graph. We also know that it takes 2 pi to go one complete revolution. So halfway around the circle is at pi. Then we go in the negative direction for the rest. So that gives us to 2 pi. And this would repeat. If we kept going, we'd have a negative pi for our next intersection point, positive or negative 2 pi for the next one, and it would be the same thing in the other direction. So our x-intercepts end up being every pi or multiple of, so we can write that as x equals pi n. The amplitude now from the graph is the height of the graph from the x-axis. So from the x-axis, our normal graph has a height of 1, and the last one, the period, is the length of the graph in the x direction for one complete revolution. So we started at 0, we end up at 2 pi, so we'd say our period of a regular sine graph is 2 pi. Every 2 pi or 360 degrees, it's going to repeat. So now what we do is we take that information and tie it to a sine equation. So you're going to get equations that are in this form, y equals a sine b of x, so we just got to figure out what the a and the b are in terms of a graph. So remember from our unit 1 stuff, if we have a number in front like a, that's going to be our vertical stretch. So in terms of a sine graph, if our regular amplitude is 1, we have a height of 1, but if I put this a at 2, what that's going to mean is it's going to double it. We're going to make it an amplitude of 2. If I put it at 5, it's going to be an amplitude of 5, and it would also go down to negative 5. So the a number is our vertical stretch, so that's easy. So whatever that number in front, So A equals amplitude, which is also equal to our vertical stretch. The B number now is, remember B is our horizontal, so we'd have 1 over B. Remember from our first unit 2 we always got to do the flip, so 1 over B would be our horizontal stretch. And it doesn't give us the period, but it is related to the period. So if I had a normal graph of period of 2 pi, and I told you let's make it a 2 times horizontal stretch, that would double it, so that means our new period would be 4 pi. If I said our original was 2 pi and I did a half horizontal stretch, well, that would cut the period to 1 pi. So our period and our B are actually related to each other, so we just have to figure that out. And there is a formula for that. First of all, the amplitude we said was the actual height. But from a graph, sometimes it's easier to use the coordinates. So let's suppose we had a sine graph that went from maximum of positive 4 down to a minimum of negative 4. We could see that our amplitude from the graph is at 4, or we could use the formula of 4 take away negative 4 divided by 2, which would give us 8 divided by 2, which is 4. So either way, it's pretty easy. Usually just go from the x-axis up, makes it more straightforward. And then our period is, the formula is going to be 2 pi divided by whatever the B number is in your equation. Because remember B, if it was 2, that means we went half as much. So we'd go 2 divided by 2, which would give us 1 pi. So our regular graph of 2 pi period would then be 1 pi. Or in degrees, we'd use 360 divided by B. Okay, so let's go through a few examples and we'll see how this works. So for this first equation, it's saying find the amplitude and period. So our amplitude in this case is 1. We have no number in front, but it can always be a 1. Our B number is 3. So from that, we know then our period is 2 pi divided by B, or 2 pi over 3. And from that, we can basically sketch our graph. So we want to go, in this case, from 0 up to 3 pi. That's what our question tells us to go to. Okay, so we know we have an amplitude of 1, so that means we're going to go from 1 to negative 1. That's our regular graph. So remember, our regular graph should be, oops, I got that a little bit off. Let's fix that. So our regular graph should go up to 1 and down through pi to negative 1, and then back up through 2 pi and so on. So our regular graph should look something like that. My first part's a little bit crooked. So something along those lines would be our regular sine graph. So the only thing that's changing, our A is still 1, so that doesn't change, but our period is 1/3 as narrow. So our period is 1/3, so you can think of just shrinking this 3 times smaller. So you can see that basically we're going to get 1 complete cycle, just like I've drawn here, within the 1 pi. Or, if we use the formula, draw it as 2/3. Okay, so our period of 2/3, so let's separate these things into thirds. So if we have pi, so we can go 1/3, 2/3 pi, and then we'd have 4/3, 5/3, 6/3, and so on. So if we cut these into thirds, that might make it easier. So now a period of 2/3 means we've got to do 1 complete cycle in 2/3. So that means we've got to go up, down, and back again in 2/3. So that's our 1 graph. Now we can basically just keep repeating it, up, down, and back, up, down, and back, up, down, and back, and then we'd have 1 more like that. So you can actually see, if you kind of compare the dotted line, the original, to the blue line, original we had 2 humps in 1 valley. Now we got 1, 2, 3, 4, 5, and 4. So you can see we actually did a 3 times stretch. Or you can kind of think of it as like in the original we got 1 from 0 to 2 pi, we got 1 complete cycle. So now if you look at the blue one, we got 1 to there, 2 to there, and then 3 in the same distance. So we've actually got 3 graphs now in the same distance, which would be 1/3 in terms of a horizontal stretch. Okay, so let's try another one. This one we've got our A of negative 4, and our B in this case is 1, which means our period is 2 pi over 1, which would just be 2 pi. So in this case, we got a regular horizontal, but our vertical got stretched. So we were going from negative pi to 2 pi, so let's sketch that out. And normally our graph would start at 0, go up to 1, and negative 1, so we'd have kind of a graph that looks something like that. but we know now that we're going to be flipping it. The negative means a vertical flip, so it's going to go upside down. And the 4 means we're going to go an amplitude of 4, so it's going to go from 4 down to negative 4. So we can draw it upside down to negative 4, and it'll go up to 4 like that, and then we'd have another one in the negative direction, something like that. So these are usually pretty easy. Once you know the period and the amplitude, you can usually get the graph pretty straightforward. Okay, here's another one. This one's in degrees. Our amplitude is a 0.25 or a quarter, and our B is also a quarter. So that means our period would be 2 pi, or this one's in degrees, so let's use 360 divided by a quarter, which would actually be 360 times 4, which is 1440. So this graph, we're going to be starting at 0, and we're going to go 180 to 360 to 720, around again, and around again to get to our 1440. Okay, so our regular graph would have a height of 1, and it would do 1 complete cycle in 360, so let's kind of sketch that in again. Okay, so our regular goes from 0 to 360, from 1 to negative 1. Okay, so that means our amplitude of a quarter, we're going to be going only a quarter as high, so it's going to be pretty low. But now we're also going 4 times wider. A B of 1 quarter means we went 4 times wider. So we're actually going to go halfway to 720, and then we're going to complete our cycle at 1440. So our graph would actually be pretty wide and low, something like that. Okay, our next little topic now is just to see how a cosine graph is different. And if we went back to our unit circle, let's go back to the title page. We saw that with our unit circle, the second coordinate was our sine value. Our cosine value is the first coordinate. So our cosine is going to start at 1. Then we're going to go down to 0. We go 1 to root 3 over 2 to 1 over 2 to 1/2. And then eventually at 0. So our cosine is going to go down to 0 first. Then it's going to go from 0 to negative 1. So it'll do that kind of graph. Then it's going to go back to 0. And then it's going to go back to 1. So it repeats, and it uses the same value, so it ends up being just like a sine graph, but we end up getting it just sort of shifted over a little bit.
Can I get this, please, if you're going to 0?
So with our cosine graph then, it looks exactly like a sine graph, but just shifted over a little bit, and the key difference is it's going to start at 1 instead of at 0. So our starting point's at 1 instead of the origin. We still have the same amplitude, still have the same. So our maximums are still the same. Y-intercept is now 1, and our x-intercepts change. Remember with pi, for sine, our intersection points were pi and 2 pi, and so on. In this case now we're switching over 90 degrees, so we'll be at 90, 270, and so on. So they're going to be pi by 2, 3 pi by 2. And that's it. So our amplitude stays the same, period stays the same. The only thing that's the key difference is our y-intercept is going to start at 1. So let's do a few questions now where we're going to look at graphs and figure out what the equation is. So these ones are sometimes a little bit harder. So what you want to first of all do is figure out what kind of graph. So you can see this first one, we're starting at 0, so that should be a sine graph. And you can see for the second one, we're starting at 1, so that should be a cosine graph. That's the really only thing you got to be careful of in which graph's which. Now, the next step is figure out the amplitude. So here you can see our maximum height of the graph is 1/2, or 0.5, so our amplitude would be 1/2. If we go over to this one, our height of the graph is at 1, so we just have a 1, or we don't even need that number there. And if we look at now the first graph, our period is from 0 to 2 pi. So if our period is 2 pi, remember now we basically just go 2 pi divided by b to get period, or we can go 2 pi divided by period to get b. So 2 pi divided by 2 pi is 1. So that means we just get sine of 1x. And we don't need to write the 1 in there, so this equation would be 1/2 sine x, and we're done. Okay, do the same thing for the second one. We can see now our period, we're starting at 1, we're going down, back up to 1. So our period in this case would be 2 pi over 3. So our b value will be 2 pi divided by 2 pi over 3. If you do that fraction, you'd end up getting 3. So in this case, we got 1 cos 3x, and we don't really need the 1. We can just write it as cos 3x. So we can see that our graph is 3 times narrower, which looks right. If our original is to 2 pi, we now have 3 times skinnier in terms of the graph. And let's do a couple more. Here, this one we're starting at, we're not at the 1, we're at the 2, but we're still starting at the top of the thing, so we know that that's got to be a cosine graph. And our amplitude is going from 0 to 2, so we have a 2. And our period, 1 complete cycle, is at here. So if we look at the graph carefully, that is halfway between pi by 3 and 2 pi by 3. Pi by 3, remember, is 60. 2 pi by 3 is 120. So that means halfway is at 90, or pi by 2. So our period is pi by 2. It should be 2 pi. So we'd go 2 pi divided by pi by 2. Oops, that's our b value, not our period. So 2 pi divided by our period of pi by 2. That gives us 2 pi divided by 2 would give us 4. So that means our formula should be 2 cosine 4x. So in this case, we've got 4 graphs in the time it would take just the one regular one. So that's it for that one. Our last one, we've got our origin, so we know it's going to be a sine graph. We look at our amplitude, we're going up to 1.5, so you can leave it as a decimal, or you could use 3 halves as a fraction, whichever. And our period, we can see we've got half of a graph that's at 3 pi. So that means our period would be 6 pi. So that means our b is going to be 2 pi divided by 6 pi, which would be 1/3. And that would be it. So we'd have 1/2, 1.5 sine of 1/3 of x. And with these kind of questions, it's a good idea if you want to graph your final equation and then compare that to what your calculator shows to what the question is. If they match, then you know you've got the right equation. And that's it.